So welcome to our online classes. This is our first lecture and it is all about uniform circular motion. So here we go. So what is uniform circular motion? Anything which moves in a circle is a circular motion. For example, a car moving around a roundabout, we call it circular motion. If we tie a stone on a rope and move in a circle, it is also a circular motion. If this car moves in a circle with constant speed, we call it a uniform circular motion. Keep in mind that I have said constant speed, not constant velocity, as it continuously changing direction. According to the definition of its acceleration, it is actually the change in velocity. As velocity is a vector, so it can be changed with respect to its magnitude and with respect to its direction. In a uniform circular motion, as mentioned earlier, magnitude is constant, and acceleration is actually the result of change in direction. Now, as far as the direction of the acceleration is concerned, because we have strict the motion that the body has to move in a circle with a constant velocity. In these kind of conditions, the acceleration is always directed toward the center of the circle and always perpendicular to the path. As far as the magnitude of the acceleration is concerned, we have to consider two vectors. One is the position vector, the other one is the velocity vector. As there are two states, position A, position B, the position vector corresponding to the position A will be considered as Ri, and the position vector corresponding to the state B will be considered as Rf. Similarly, we have Vi and Vf. The change in position is will denoted by del R, and the change in velocity will be denoted by del V. Now you can see in the diagram that we have two positions A and B. The velocity at position A will be Vi and the velocity at position B will be Vf. As we already know that velocity is constant, so we understand that Vi must be equal to Vf. Same, the position vector from the center of the circle for position A is Ri and position B is Rf. The angle between the two vectors will be del theta, and it is same for velocity and position both. What I have already explained in diagram, it is written in this slide, so you can understand if you didn't understand in the diagram. Okay. So both triangles are similar in a condition if we have one angle which is same or equal, and the ratio of the two sides are equal, that Vi, Vf and Rif both are equal, so we can say that both triangles are same. In that condition, we can write these two equations, and with the help of the definition of the acceleration, we can write the second equation. Now finally, we have ended in the condition already famous equation. You have already learned it by heart, that AC is equal to V square over R. In the world of science, we have two kind of groups. One used to say that Einstein is the best ever physicist ever born in this world, and the other group says Sir Isaac Newton is the best ever physicist. But both are agreed that if Sir Einstein is first, then Sir Newton will be the second one. Whatever, we have the boom, that is the blast in the whole world, and it is the concept of force which was given by Sir Isaac Newton. As far as the definition of the force is concerned, we can write it is an agent which can cause the motion, which can stop the motion, and it can also change the direction of the motion. We have two different types of forces, the contact forces and the field forces. Clear from the name, it is a contact forces, so it requires the physical contact. So we have some example. We have a spring, a cart, and a player kick the football. All these forces can be considered as a contact forces. Now here the second type, the field forces, opposite to the previous one. It does not require any kind of contact. They can act through empty spaces. There are some examples you already know about them. The famous universal law of gravitation, gravitational force, the force between the two charges, and the force between the two magnets. So these all are the field forces. One of the important concepts, the inertial frame of reference. So if an object has a zero acceleration, means does not have any velocity, means at rest, or it has a velocity but does not change, a constant velocity. So we can say that the frame of reference in which this object is present can be identified as an inertial frame of reference. Newton's first law of motion is responsible to define these type of reference frames. I used to explain my students that first law of motion is very important, and why I admire Sir Isaac Newton, because it sense or imagine the motion which cannot be seen by anyone in the earth on in his from his eyes, because it tells about a body which which is in a state of motion will remain in the state of motion. It is not possible. You can throw a ball, it will stop. You can hit the ball, it will stop. So they imagine this kind of motion. That is the very important thing about this first law of motion. So what we can say as a statement is that if there is no external force, then the body which is in a state of rest will remain in the state of rest. And if a body is in a state of motion, it will remain in the state of motion with constant velocity. You have to remember that because of this explanation, the first law of motion is also known as the law of inertia. Now this is the second law of motion. Everyone knows about it, F is equal to ma, but as far as the statement is concerned, we have to say that acceleration is directly proportional to the force applied and inversely proportional to the mass of the body. That is the second law of motion. Or we can write, if we apply a force on a body, it will move and it will accelerate. Obviously, if we apply the force, it will change the state of a body. If it is at rest, it will continue the motion. If it is in motion, it will stop. It can be in a rest. Or if it is moving with a constant velocity, it will accelerate. Something change in the velocity, whatever. But body accelerates, and the direction of the acceleration is always along the direction of the force.